Alright, this is the test for the input selector. We have our circuit here, which is really complicated when you look at it, but I have a schematic to display what I'm doing. So if we go over here, basically what we're going to do is we have the multi-channel input, which runs through, which is triggered by 1, runs through 3 to the 6 primary outputs. And then we have a 2-channel input which runs through 1, an 1/8 inch input which runs through 1, and the coaxial digital which runs through 1 and to the outputs down here. What we're going to do is we're going to lead 0 or 5 volts to each of these in order to trigger the correct outputs, and then we're going to determine whether or not we receive the sine wave output on the oscilloscope over here. We have the input signal displayed. Let me double check that. Yes, we have the input signal displayed at the top, and we have the output signal displayed at the bottom. The only thing we need to see here is that when I give the input a signal, we'll see a sine wave. It's just 1 kilohertz, peak, 2 volts peak to peak. And the output, if it's on, we should see the same thing. If it's off, we should see essentially 0. So our setup initially is that bits, come back over here, bits 1, 2, and 3 are all tied to ground, so they'd be logical zeros. This would indicate that this device right here, this relay, would switch on, triggering another 5-volt line to these. And we did this because we discovered in testing that this chip could not supply enough current to maintain the voltage high enough across these to trigger them on. So we're using another relay right here to turn these on. So, as we'll see over here, I've tied the first 2 inputs to a signal, which is essentially the center and subwoofer relay, as those 2 signals will be running through this chip. And I have tied the inputs off of those to ground, ground, and ground coming off the power supply. You're more or less going to have to believe me on that because it's impossible to show beyond this. And now, as we supply a sine wave, and we have an input and output. And to prove this, I'll go ahead and switch pin 1 to a hot, and that will give proof that if I change the setting, the input is lost. And there you have it right there. I lead pin 1 to a 5-volt source, and it goes off. Back to ground, back on, 5 volts off, on, off, on. And now we'll go through each of the channels and prove that they all work.